Hello students, today let us learn a bit more about chemical reactions. In our previous video we have seen a number of reactions. We have learned about physical changes and chemical changes in our daily life which are related to these chemical reactions like curdling of milk, rusting of iron, fermentation of grapes, respiration which we do every day, every time. Then you can see this picture, some of the changes that we observe here. Color change in fruit, color change of bread when it is roasted, then rusting of iron nails and burning of matchstick. All these are related to chemical reactions. These changes are related to chemical reactions. Then what is this chemical reaction? Let us consider one example. Observe this given picture here. Wood is burned. Wood is nothing but hydrocarbon. So this hydrocarbon takes oxygen from its surrounding. As you can see here, oxygen is very essential for combustion. Without oxygen there is no combustion. So wood, in the presence of oxygen, when it reaches a particular ignition temperature, it burns and produces carbon dioxide and water vapor. Carbon dioxide and water. So here we have taken the reactant, that is solid, and by using the oxygen from the atmosphere, these two are the reactants. These two combine and undergo a change, undergo a reaction and give rise to carbon dioxide, water. Carbon dioxide, water in gaseous form. It is getting liberated here along with the heat and light, as you can observe here. So, what is this chemical reaction? Chemical reactions are the process. This is one process in which new substances, as you can see here, before burning of wood, we didn't have carbon dioxide and water. But after burning, we are getting carbon dioxide and water. Don't you think these are the new products? Yeah. Carbon dioxide, water, the new products are liberated out. These new products have new properties. These new substances have new properties. They are gaseous in nature. So such a process is termed as chemical reactions. Chemical reactions are the process in which new substance with new properties are formed. Let us consider one more example. Here, iron is absorbing the oxygen from the surrounding, and in the presence of moisture, it is getting converted to iron oxide. Iron oxide. Fe2O3. Fe2O3, the formula of rust, iron oxide. So, here we are getting a new product with new properties. So, this is an example for chemical reaction. Let us consider one more. Let us understand chemical reaction with one more example. Here, hydrogen gas and oxygen. This is hydrogen, this is oxygen. As we all know that hydrogen is highly combustible. Oxygen supports combustion. These are the two reactants. When these two reactants combine, it gives rise to a new product with new properties, that is water, H2O. H2 and O. This water is used to extinguish fire. Don't you think that it has got new property? Yes. So, we term this type of change, this type of reaction as a chemical reaction. Hydrogen, oxygen combine to give water, which has got a complete new properties, new product. So here is an example for chemical reaction. Hydrogen is a gas, oxygen is also a gas, but we are getting liquid water here. Hydrogen is highly combustible, oxygen supports combustion. But when these two combine, we get a product which is used to stop the combustion. Yes. Let us understand more about chemical equation now. What is this chemical equation? The method of representing a chemical reaction with the help of symbols and formulas of the substance involved in it is known as chemical equation. As you have seen in the previous example here, hydrogen gas and oxygen gas. To represent hydrogen, I am using the symbol H2. To represent oxygen, we use the symbol O2. Don't you think it is easy to understand and practice and learn? Yes. So, instead of writing hydrogen and oxygen gas in words, we can simply represent it as H2 and O2. And instead of writing it as water, we can write it as H2O. So this way of representing in a symbolic form, representing a reaction in a symbolic form is termed as chemical equation. So this type of understanding and writing a chemical reaction with the help of symbols is termed as chemical equation. Method of representing a chemical reaction with the help of symbols and formulas of the substance involved in it is known as chemical equation. Now, let us learn the important characteristics of chemical reaction. As you can see in this picture, here we have taken some chemical in the test tube, and when we are heating it, you can observe some of the important characteristics of a chemical reaction. You all know that chemical reaction is taking place. How do you tell that it is a chemical reaction? You need to observe some important characteristic in it, isn't it? Yes. What are the important characteristic you need to observe here? Yeah. Now you can see there is a color change, evolution of gas, change of state, change of temperature. There is a temperature change also. You can see bubbles are coming, then temperature is increasing, then precipitate is formed. Solid precipitate is formed inside the test tube. Yes, these are the important characteristics of chemical reaction. Change in state. When a chemical reaction takes place, there will be a change in state. Solid to liquid, liquid to gas. Second, change in color. You might have observed here. You can see here in this picture, there is a change in color. Observe carefully, the color is changing. Third, evolution of gas. When you see now, the gas is evolving out. So whenever there is a chemical reaction, these are characteristics. All these characteristics or some of these characteristics is observed. Change in temperature. Slowly the temperature of the test tube and the content in the test tube increases. Then formation of precipitate. Sometimes the solid residue precipitate remains in the test tube. So these are the characteristics of chemical reactions. Let us move on for the next one and understand some of the important things in a chemical reaction. The substance which undergo a chemical change in the reaction are called reactants. To understand a chemical equation or chemical reactions, we need two important things, that is reactants and products. So reactants are the substance that undergo a change. For example, zinc and sulfuric acid. Zinc reacts with sulfuric acid. These are the two reactants and it gives rise to some new substances. So, the substance that is undergoing a chemical change is termed as reactants. So, what are the reactants here? Zinc and sulfuric acid, H2SO4, are the reactants. Then, what are the products? Yeah, when zinc and sulfuric acid, these two reactants combine, we are getting the new substance. These new substance with new properties are termed as products. So, the new substance formed during a chemical reaction are called products. These are the new substance with new properties. What is a skeletal equation? If the number of atoms of any element in a chemical equation is not equal on both sides, then it is called a skeletal equation. Always the reactants and products must be equal. If the number of atoms on reactant side is not equal to number of atoms on product side, such an equation is termed as skeletal equation. Now let us understand. Can you identify this symbol? Yeah, this is the symbol Mg for magnesium. Here we have magnesium atom. This magnesium atom, which is a reactant, is combining with hydrochloric acid, HCl. This is a molecule compound hydrochloric acid, HCl. So here we have one atom of hydrogen, one atom of chlorine. So when these two combine, we are getting magnesium chloride. So to form a magnesium chloride molecule, MgCl2, there should be two atoms of chlorine to combine with one atom of magnesium. Two atoms of chlorine combines with one atom of magnesium and it forms magnesium chloride. Plus with the liberation of hydrogen gas. We know that hydrogen gas is always in a molecular form, that is H2. Now, is the reactants and products equal? We have one atom of magnesium, one atom of magnesium, right. But one atom of chlorine here and two chlorine atoms here. So, here it is not equal. Chlorine on reactant side, number of chlorine atoms on product side is not equal. Therefore, such a equation is termed as skeletal equation. You can see again here hydrogen also. Here hydrogen is 1. We have only one atom of hydrogen on reactant side and two atoms of hydrogen in the product side. So number of atoms on reactants and product side is not equal. Such a equation is termed as skeletal equation. Then what is balanced equation? Yeah, very simple. A balanced chemical equation means total number of atoms of each element is equal on both the side of a chemical reaction. If the number of atoms on reactant side is equal to number of atoms on product side, then such a equation is termed as balanced chemical equation. Observe this equation here. Magnesium is 1, magnesium 1, right. Hydrogen is 2, hydrogen is 2. Chlorine is 2, chlorine is 2. So here this equation, number of atoms on the reactant side is equal to number of atoms on the product side. So such a equation is termed as balanced chemical equation. Magnesium, this is all about reactant side, product side. LHS should be equal to RHS. Mg1, Mg1. Hydrogen is 2 here, hydrogen is 2. Chlorine is 2 here, chlorine is 2. So number of atoms on the reactant side is equal to number of atoms on the product side. Let us move on and understand more about this balanced chemical equation. For example, we have taken 30 kg of wooden log, and the fire is 1 kg. What is the total now? 30 plus 1, 31. And the ash formed is 28 kg and the smoke is 3 kg. For example, 28 plus 3, 28, 31. Yes. So, what do you think? Is this a balanced chemical equation or not? Yes. Number of atoms on the reactant side, mass on the reactant side is equal to the mass on the product side. Therefore, atoms are equal. Such a reaction is termed as balanced chemical equation. Why should an equation be balanced? This is the question now. Yes. A chemical reaction should be balanced because matter can neither be created nor be destroyed. The total mass of the reactant should be equal to the total mass of the product. It is on the basis of law of conservation of mass. Dear students, we all have learnt about law of conservation of mass. Mass can neither be created nor be destroyed. If you are burning one paper, that one paper remains as ash, plus there will be evolution of gas. That gas will be present in the atmosphere. You cannot destroy that carbon dioxide. If it is absorbed by plant, that carbon dioxide goes into the plant body and takes the form of carbohydrates. That carbohydrate, when it is consumed by the animals, it will remain in animal body as a mass. Again that animal die or it is eaten by some other, again it will go from one body to another body. Yes, this is a logic of nature. We cannot create mass, we cannot destroy mass. Law of conservation of mass. Mass can neither be created nor be destroyed, but it can be converted from one form to another form. Now, let us understand about the types of chemical reactions. Based on whether heat is liberated or heat is absorbed, we can classify the chemical reaction into two forms based on absorption or liberation of heat. So, observe this given image. Here, ice is melting. Dear student, we all know that if something needs to melt, it needs to get some energy. Some heat should be supplied for it to melt. Isn't it? Now, if the ice is melting here, to melt ice, it needs some energy. Who is supplying this energy for the ice to melt? Guess right. So, water has some heat. As soon as you put some ice in water, the water becomes cool. Where is the heat gone? Yeah, the heat of the water is taken by the ice, is absorbed by the ice to change its state from solid to liquid. The heat is absorbed for purpose of melting. It is changing its state from solid to liquid. To do this, the heat is supplied by the water to the ice, liquid water to the solid ice for the purpose of melting. So here the ice is absorbing the heat from the water. So whenever heat is absorbed, we term such a reaction as endothermic reaction. Endo, taking in. Heat is taken in. Such a type of reaction is endothermic reaction. Here ice is melting by absorbing the heat from the water and its surroundings. Since heat is absorbed, it is an example for endothermic reaction. Now can you tell me what type of reaction is this? Yeah, you are seeing in this reaction, heat is taken in or given out? Yeah, heat is given out. So, such a reaction where heat is given out. Out. Such a reaction is termed as exothermic reaction. On burning wood, heat is liberated. Therefore, it is an example for exothermic reaction. Now, based on the type of reactants, we can classify the chemical reactions into these 4 types. First one is combination reaction. Second, decomposition reaction. Third, displacement reaction. Fourth, double displacement reaction. So these are the 4 important types of chemical reaction. Based on the process or reactants, how the reactants combine or how the reactants show its process, we classify this chemical reaction into this 4 basic types, that is combination reaction, decomposition reaction, displacement reaction, double displacement reaction. Let us learn about this type of chemical reaction in our coming classes. So before we say goodbye, let us take some homework question. Are you ready, students? Yes, this is very simple 3 questions based on the content that we have discussed here. So the first question is, write the difference between exothermic and endothermic reaction. Think and write your own answer. Second question is, list the types of chemical reactions. Third question is, give example for exothermic reaction. In your daily life, you might have observed so many exothermic reactions. So you need to give example from your daily life for exothermic reaction. Write the difference between exothermic and endothermic reaction. Second, list the type of chemical reactions. Third, give example for exothermic reactions. Thank you. Have a nice day.